Right, so it's in terms of composition, it is very important that we recognize the opposite of as a factor of -1 in the term. So here's where we have a combination of factor operators. So say I want to take the opposite of the square root of 9. Now, again, if we see something like this, the opposite of would look like this. So it's the opposite of, and then in parentheses, the square root of 9. All right, so this is what you would probably see. But this is kind of an overuse of grouping symbols. So what you're going to see is that this negative is just in front of the square root of 9. So that's how you'll see the opposite of the square root of 9. Now it makes sense when we evaluate this is that we think of taking the opposite of when you evaluate it, we think of it as taking the opposite of, and then what's the square root of 9? We need to find the square root of 9 first, and then take the opposite of. So of course the opposite of -3 is, the opposite of +3 is -3. So the answer to this is -3. We want the operations. Now, let's say we see this exact same expression and instead of worrying about the opposite of, because this is a negative sign outside of grouping symbols, instead we're going to look at this as in terms of factors. So the negative sign outside is going to represent a factor of -1. So instead of taking the opposite of, we're just going to apply a factor of -1. The square root of 9 is another factor. Now, when we evaluate this, we know we have to find the factor values and then multiply. So the factors are -1, the square root of 9 is 3, and -1 times 3 is -3. So again, instead of worrying about the opposite of, we will just identify that factor of -1. So it's outside of the operator. We'll just use a factor of -1 and then not worry about the order. So let's see an absolute value. If we have an example of an absolute value, the opposite of would be a negative sign. The absolute value of -5 would be the absolute value, -5. So again, when we think about evaluating this, instead of taking the opposite of the absolute value of -5, so that'd be the opposite of, well, the absolute value of -5 is 5, and the opposite of +5 is -5. So instead, if we have the opposite of the absolute value of -5, we're going to recognize factors instead. So the factors, negative, or the opposite of, is going to be a factor of -1. And then the absolute value of -5 is the other factor. So when we evaluate, that's the absolute value, isn't it? So this is the absolute value of -5. Oh, man. So we need to know the absolute value of -5. That factor value is +5. -1 times +5 is -5, which is the same. Okay, so let's look at the next two. And these two are going to probably be, one of them is easy. The other one is going to take some getting used to. The opposite of negative 4 squared. Now, what you're going to see is the opposite of would just be the negative sign. Now, negative 4 squared, if I want to square negative 4, I need to put it in parentheses to square it. So this is actually what you would see, is the negative sign in front of the parentheses, grouping the negative 4 to be squared. All right, so instead of thinking about the opposite of negative 4 squared, again, we can do that. The opposite of negative 4 squared is negative 4 times negative 4, which is positive 16. And the opposite of 16 is negative 16. So we can get our answer that way. But instead, when we see the opposite of negative 4 squared, we want to recognize the factors in this term. And then we can allow composition. So you notice this negative 4 squared is in parentheses, so the opposite would be a factor of negative 1. So we'll just keep track of that. Negative 4 squared is a factor of negative 4 and negative 4. So again, the factors of this term. Now, once we have individual factors, we can multiply in any order we want. It just so happens this one, it really doesn't make much sense, but negative 1 times negative 4 times negative 4 is 16. Negative 1 times 16 is negative 16. So again, we're getting the same answer, but we just want to make sure of what we see and how we treat it. In composition, I want us to be able to, and you want to be able to have the ability to recognize factors in a term. So what we're doing is recognizing a factor of negative 1. And so far, all the factors of negative 1 have been outside of grouping symbols. That negative sign is appearing outside of grouping symbols. So here's the next one. And I want to leave it here and show the difference. The opposite of 7 squared. Now, it would make sense to write it as the opposite of, and then in parentheses, 7 squared. Now, if it was written like this, this would be logical. But in terms of mathematics, this is actually what you'll see. They figure this, the parentheses that's grouping the 7 is not needed because it's not a negative. So with the negative 4, I want to be able to group that to make sure you're squaring negative 4. Make sure the factors are negative 4. But here's what you'll see in an expression. And this is really complicated because the way we read it even might be wrong. And we might even read this as negative 7 squared. But we're supposed to be reading it as the opposite of 7 squared. Now, if we think of this the same way as we did with our other terms, the negative sign is actually outside of the power. Now the power groups this together, but this factor would be a factor of negative 1. And then the 7 squared would be 2 factors of 7, positive 7. So the factors in this term are negative 1 because of the outside, the negative sign outside, and then 7 squared because the 7 is the only base or the only factor of 2. So again, this would be a logical way to see it. Just use parentheses every time you have powers. But anytime there's a positive number, the parentheses are gone. and I have to interpret the negative sign outside as a factor of -1. So -1 times 49, 7 times 7 is 49, and the answer to this is -49. Now, the reason why we do that is because if we see these types of things in an expression, we need to be able to identify terms and factors. So very quickly, the first expression here, there's actually two terms. The first term has a value of 50. The second term has factors of -1, 7 times 7. So again, this negative sign is outside of the power of 2. I have to remember that. So this term value is -49. When I find the value of this expression, I want to combine the term values. I get 1 for an answer, +1. But in this expression, you notice I have the same type of things, but they're a different composition. In this one, this is just one term. So before we had two terms. The negative sign was signifying a new term. And here I have one term because the negative sign is inside of parentheses. So if it's one term, it just has separate factors. And this would be a factor of 50 times a factor of 49. And 50 times 49 is 2,450. So it's really important that we keep track and understand how factors of -1 are identified in an expression. Again, anytime we have square root, negative sign is outside of that factor operator. So it's a lot easier to identify. The same thing with absolute value. The negative sign is outside that absolute value. If I'm using a power of a negative number, again, the parentheses have to be used. So the negative sign is outside those parentheses. This is the only time if the factor or if the base is positive, this is the one that we need to watch for. Okay, they are not the same. The base is positive if that negative sign and there's no parentheses.